as we begin this disc, I want to put a special emphasis on the why and the how, because we're going to start with nothing and end up with a helicopter that flies perfectly. We do this by understanding the why through the theory, and then I'll show you the how using the T-Rex 450 as an example. So once you understand the why and the how, you'll be able to set up any radio and any helicopter with absolute precision. As we begin the radio theory section, I have to apologize because this information is going to be intense. We're going to cover every item in the DX6 and the DX7 radio and evaluate how the radios work and how each feature should be set up in the helicopter. To help break things up a little bit, I'm going to intersperse some flying shots as we go along. The good news is that once you digest this information, you'll have a complete understanding of how these radios work. Now, you'll have to watch the DVD more than once to pick up all of that information, but once you pick it up and you understand it, you'll have it. And that way, the setup will be a piece of cake. Assuming you haven't purchased a radio yet, I just want to go over the different features between the DX6 and the DX7, and really, if you can afford it, I want to convince you to buy a DX7 radio for a couple of different reasons. First of all, the DX7 is now available in a Park Flyer edition, or what they call Microlight. That means that it comes with the AR6100 receiver and 3 servos. The servos are significantly better in the DX7 than in the DX6, and excuse me, I'm just going to use a little cheat sheet here, but the DX7 comes with 3 S285 servos. The DX6 comes with 4 S75 servos, and so to have a gyro servo or to have a tail rotor servo for the DX7, you obviously have to buy that. But again, the servos on the DX6, that's something that will work if you're just learning how to fly, but once you get a little bit more advanced, the S75 servos won't cut it. Now, let me just go down through and first of all, let me tell you some of the things that the DX7 has that the DX6 does not. The DX7 has auto dual rate and expo. The DX7 has the second idle up. It has a gyro sense page. It has 2 more program mixes, which will be important when we go through the theory section and teach you how to set up program mix. It has a timer and it has a servo monitor so you can see what the servos are doing on the transmitter screen. Then the DX7 is a second generation 2.4 gigahertz radio. That means that it has a faster processing speed than the DX6. The way the DX7 is right now, it has a faster processing speed than the current line of PCM radios. I talked about how the servos are a lot better in the DX7 than the DX6. The DX7 has 5 points versus 3 points for the throttle and pitch curves. That will really make the throttle and pitch curve setup. You'll really have direct control over where the helicopter hovers upright and inverted. As I said before, the DX7 has 3 program mixes versus 1. It has the gyro sense page. Big thing, the DX7 has graphs so that you can see exactly what's going on with your throttle and pitch curves. Now you can draw a graph to show you what's going on with the DX6, but I don't think too many people are going to go ahead and draw the graphs. The DX7 has easier menu navigation with 4 buttons versus 2. With the 4 buttons you can go up and down in the menu. In the DX6 you have to roll around and roll around and roll around. You can't go backwards. The DX7 has a higher capacity transmitter battery, 1500 milliamps versus 600 milliamps. You can really tell that when you're at the field. The DX7 transmitter lasts a lot longer. The DX7 has adjustable stick tension, has a bigger display. It has 20 models versus 10 models. It has a more versatile trainer system, and it has a swivel antenna so it'll fit into your Align T-Rex 450 transmitter box, whereas this antenna does not swivel. It just folds over. So those are some of the reasons why I'd like to encourage you to buy a DX7. Will the DX6 do the job? Yes, it will, and it's a fine radio. But for $200 for the DX6 versus $340 for the DX7. Are you getting your money's worth? Yes, you are, and more. Just because I'm featuring Spectrum's DX6 and DX7 radios doesn't mean that you have to fly the T-Rex with those type of radios, because you can use any other type of computer radio that supports eCCPM. For instance, I first started flying my T-Rex with JR's 9303 transmitter, and I used Hi-Tech's Electron 6 receiver. Since that time, JR has introduced a small, fully synthesized receiver, and this is the R790. So if you want to fly your small electric helicopter with PCM, this is a good choice. Now, the FM receiver is a little bit more subject to interference or RF noise from the belt, and I haven't found that to be any problem with using Hi-Tech's Electron 6. I didn't get one glitch when I used this receiver. In terms of the antenna, simply use Revolution's whip antenna and use some hot glue to mount it to the top servo. To do that, you'll just have to remove this little spacer that goes between the side frames. Then use a heat gun to just conform the antenna to the inside of the canopy. Now, before we get too deep into the DX6 and DX7 transmitter menus, let's go over exactly what E or electronic CCPM is. First of all, there's MCCPM, which is mechanical CCPM. It's more complicated mechanically in the helicopter, but very simple to set up, since the collective pitch and the cyclic are totally independent. On the other hand, electronic or eCCPM is very simple mechanically, because in the T-Rex 450, there are only 3 push rods going from the servos up to the swash plate. However, it's more involved when you set it up through the transmitter, because the collective and the cyclic are mixed together electronically through the transmitter. First of all, eCCPM in our application is going to be composed of 3 servos, each 120 degrees apart. That's why it's called 120 degree CCPM. Now, when we plug these servos into the receiver, the only critical servo is channel 3 or elevator. It must be plugged into the elevator channel. And we'll see this in the DX6 when I give some examples, but these 2 servos can be plugged in to channel 2 and channel 6 or channel 6 and channel 2. It makes no difference. So I simply plug in the roll servos so that they match up with the receiver. For instance, if this is the way the receiver is mounted in the helicopter, aileron is right here, so I'll put the aileron on the left side, and again, this would be forward in a helicopter such as the T-Rex 450. And so here would be, over on the right side, would be aux, and so pitch or channel 6 or aux, all the same thing. That servo would be on the right side, and then the elevator servo would be in the middle. Again, you'll see this in the setup, but I will label the servos aileron or channel 2, elevator or channel 3, or pitch or channel 6, because that will really make a big difference when we go to other functions. For instance, when we level the swash plate at full high pitch, and when we level the swash plate at full low pitch with travel adjust, it'll be very important that when we move the travel adjust, we can see which servo arm is going to move. So for eCCPM, for collective pitch, all 3 of these servos will increase and decrease together, and for cyclic pitch, the servos will move differentially. These principles form the foundation of eCCPM. Let's take an overall look at the DX6 transmitter, and then we'll take a look at the DX7. First of all, in the top left corner, we have the flight mode switch. When this switch is back, it's in the normal flight mode, and when it's forward, it's in the aerobatic flight mode, or flight mode number 1. In the normal flight mode, we use that to lift the helicopter up off the ground and to tool around in a scale-like fashion, and then we use flight mode number 1 for all of our aerobatics, loops and rolls and that kind of thing. Here's the elevator dual rate switch. We'll actually assign the gyro sensitivity to this switch, and we'll set it up so that heading hold is in the upper position and the rate mode of the gyro is in the down position. Here's the trainer button. We've got the transmitter voltage, the name of the model, and then throttle cut is only used for a glow-powered helicopter. When you push throttle cut, it basically puts the throttle to the low stick, low trim position and is used to kill the engine. Then here's the aileron dual rate switch. We'll actually set up the aileron and elevator dual rates on this switch so that we can keep the elevator dual rate switch free for the gyro. Here's the throttle hold, flip it on and flip it off. Then on the face of the transmitter we have digital trims. The digital trims are very nice because we have separate trims for the normal flight mode and flight mode number 1. So for instance, here we're in the normal flight mode, and let's say I beep this to the left up to +10. And then if I go into the aerobatic flight mode and beep to the right, it goes to -2, so you can see that the aerobatic flight mode was still at 0. And so the digital trims are very nice. Then here are the two little buttons that we'll use to cycle through the transmitter menu. Now let's take a look at the overview of the DX7. It's similar to, yet different from the DX6. First of all, the flight mode switch is in the same location, but we've got an extra flight mode. So here's the normal flight mode, aerobatic flight mode number 1, and flight mode number 2. Here's the elevator dual rate switch, the gear switch. We have some options that we'll look at for the gear switch. When the transmitter is in the trainer mode, we push this button up to get into the trainer mode. Otherwise, in the normal flight mode, it's used for hovering pitch. Here is hovering throttle, and both hovering pitch and hovering throttle just vary the middle points. So for instance, here I have the throttle curve. It's in the normal throttle curve. And if I blip the hovering throttle up, it will take the middle points 1, 2, and 3 up, and I can just beep it once or twice or as many times as I want to, and it'll also pull all of those 3 points down. Here's the aux2 switch, the aileron dual rate switch, the throttle hold switch, and then we have digital trims for all of the flight controls. The difference here is that the digital trims are active for every flight mode. So they're active for normal, flight mode 1, 2, and throttle hold. For a little demonstration, here we're in the normal flight mode. I'll put in a little bit of left cyclic trim. Now if I flip into throttle hold, you'll see that trim come back to center, and if I go and give some right cyclic trim for throttle hold, that'll deflect off to the right. If I go out of throttle hold, my trim is back to the left. So these trims are much nicer than the DX6 because you can see what's going on all of the time. Finally, we've got buttons to scroll through the menus. These buttons are much nicer than the ones in the DX6 because we can scroll up and down and backwards, whereas in the DX6 we could only roll through the menu one way. So that's an overview of the DX7 transmitter. Now let's look at the system menu in the DX6. The system menu is basically the same for the DX6 as well as the DX7 because it consists of all the basic parameters before we can actually set up the model. So to get into the system menu, you have to lift both buttons up and then turn on the switch with both buttons up. It starts out with the model type, whether we want helicopter or aircraft, and we want helicopter. Next is the reset. To reset the entire model, you move the left button down and the right button up at the same time. And now that model is reset. Next, we have the switch assignment for the dual rates. This is elevator and aileron, meaning that the dual rate switches are separated. We also have the option to put everything on the aileron, which is what we want. We've also got the option to put everything on the elevator, or to put it combined on the flight mode switch. We want everything on the aileron switch. Next, we've got the gear assignment. F is the flight mode switch, H is the throttle hold switch, A is the aileron switch, and E is the elevator switch, which is what we want. I've just showed you how to assign the gear channel to the elevator switch. And we'll use the up position for heading hold and then the down position for rate mode. It's important, or it's necessary, that we set this up for manual selection, because when we adjust the length of the tail rotor pushrod during the initial flight trimming, we need to do that in the rate mode. Once that's all set, then we'll go up and fly in heading hold. Now, here's something else that you can do after you get your tail rotor sorted out. Go ahead and assign the gear channel to the throttle hold switch. You want to make sure that heading hold, or the plus number, is in the back position and that the rate mode is in the forward position. So what will happen is that you're in the back position, you'll have heading hold for the normal flight mode and flight mode number 1, and then when you do an auto rotation and flip this switch forward, you'll have rate mode for autos. So it's not auto gyro sensitivity like the DX7 has, but it essentially works the same way. And if you're doing autos with the DX6, it really works great. The model, pretty straightforward. Model 2, Model 3, up to 10 models. Next is the model name. You can go ahead and you've got 3 letters or numbers to assign it any name that you'd like. And there we've rolled all the way through the system menu. We're going to do the actual helicopter setup with the DX7. So what I'm going to do is really emphasize the theory through the DX6. So you'll really have a chance to see how the servos work in this breadboard setup with the DX6. And then again, when we set up the helicopter with the DX7, you'll really know what's going on. Let's look at the system mode in the DX7. Again, just like the DX6, these are the things that are set before we ever work with the helicopter on the bench. To get into the system mode, you hold down the bottom of the scroll and the select button at the same time and power on the radio. Here we have model select, model number 2. If we want to change that, I can go to model number 3, and then to activate that, I hit both buttons at the same time, and that will give me model 3. I'll power off and go back into that. I want to go ahead and let's say I wanted to copy model 3 to a different model. I'd hit the select button, and that would bring up copy model 3 to model 4, model 2, model 1, model 5, whatever, all the way up to 20 models. So I could copy model 3 to model 4, and I could go ahead and hit the clear button, and the little arrow flashes indicating that the transfer is complete. Now I want to go ahead and go back to the select, and I want to drop down and select model 2. Back into the menu, we have swash plate type. Let's go to the board and take a look at the different swash plate types. First, one servo. This is simply when you move the collective pitch, one servo moves up and down. And this is what you'd find in an M CCPM system or a mechanical CCPM system such as the Raptor 50. For two servo, 180 degree CCPM, I have no idea what that is, and I've never used it, so we're simply going to forget about it. For 3 servo CCPM 90 degree, that just means that the servos are connected to the swash plate at 90 degrees. Now, the only thing wrong with this type of eCCPM is that there are loads from the rotor blades that come down through the linkages and try to move the swash plate. If you'll look, in this system, the whole front, or it could be the rear, half of the swash plate is unsupported. So therefore, it's a little less stable when subjected to rigorous aerobatics. For a scale helicopter, this would work just fine. Finally, let's look at 3 servo 120 degree eCCPM. This is what most electric helicopters are going to utilize. And it simply means that the swash plate is connected to the servos in 120 degree segments. So we have 120 degrees, 120 degrees, and 120 degrees. Here you can see that the even pickoff points give nice support to the swash plate. So this is really a very nice eCCPM system. Now, this isn't part of the DX6 or the DX7, but you may hear 140 degree eCCPM. I haven't used 140 degree eCCPM myself, but that simply means that this front segment, or it could be the rear segment, is 10 degrees different on each end, so the pickoff points would move down here and move down here, and the resulting arc would be 140 degrees, and then we'd have 110 degrees in this segment and 110 degrees in this segment. Next is the input select. Basically, we have the choice of what we want to assign to aux2 and the gear channels, or the aux2 switch and the gear switch in the receiver. Let's go to the board and take a look at that. As far as input select, the manual has actually made input select more complicated than it actually is. All that input select is it's telling you, or it's compensating, whether you have a 6-channel receiver or a 7-channel receiver. For instance, aux2 is channel 7, and so under the aux2 options we can assign aux2, the gyro, inhibit it, which means to cancel it out, or we can assign it to a flight mode. And the way that it's set up is that one side of the switch is normal and flight mode number 1, and the other side of the switch is flight mode number 2. You can't break this down and have normal on one side and flight mode 1 and 2 on the other side. The transmitter won't let you do it. Now, in terms of the gear channel, you can assign the gear channel to gear, aux2, gyro, or kill it, inhibit it. Now, if you have the gyro assigned to one, it will not show up in the other one. So again, we only have a 6-channel receiver, so we can forget about aux2. The beauty of the DX7 is that it allows us to assign the gyro functions to the gear channel. We'll plug the gyro sensitivity switch into gear, channel 5, and then this will activate the gyro page. So that will let us automatically, through the flight mode switch, go from one sensitivity to another sensitivity, or from rate mode to heading hold. It's beautiful. It does it all automatically in the DX7. In the DX6, you have to manually change the sensitivities or rate versus heading hold with the elevator switch. So this is pretty simple. We want aux2 assigned to aux2, which we can't access with a 6-channel receiver, and we want the gyro assigned to the gear channel so that we can get automatic gyro gain through the transmitter menu automatically when we change the flight mode switch. Moving on, we've got throttle recovery. You can activate it or inhibit it through the right rocker switch. Throttle recovery is pretty cool. Let's go ahead and take a look. It's activated, and now you can't see this in the shot, but I'm going to be beeping the throttle trim down. So let's say we have a reliable idle at a quarter trim. And again, you won't use this in an electric helicopter, but you'll use this in a glow-powered helicopter. So the engine's idling reliably. Now you move the trim down, the engine dies. Now you go to restart the engine. If you move the trim up one click, the trim will automatically come up to your last position. Next, we have the trainer. Here it's inhibited. If we hit the right rocker switch, here's the normal function. This just means that the instructor has everything until he pushes the switch, which is assigned to the left rocker, which is the hovering pitch switch. Once he pushes the switch, the student has everything. The student's transmitter has to be programmed exactly the same as the instructor's transmitter. Now, you can change over the switch to the right rocker switch if you want to, but for a helicopter, the instructor is going to have his hand on the cyclic, so it's most natural if you assign the trainer system to the left rocker switch. Next, we have P-Link. P-Link is where the instructor, or I should say the student, has all of the major functions, right and left cyclic, throttle and tail rotor, but the instructor retains control of the auxiliary functions such as landing gear and flaps. This is mainly for an airplane, so it's not that useful for helicopters. Finally, in Slave and P-Link, this assigns a transmitter to Slave, and so let's say you have two DX7 transmitters. This one will be the Slave, and its programming does not have to match the master transmitter. So that's pretty cool. And that takes us around to inhibit the trainer system. Next, we have the reset. So if I want to reset the data as well as resetting the integral time, this is the total time on the transmitter, I can just hit